Good evening, dear students of Standard 9. How are you all? Hope you are fine and safe. This is my introduction. Me, Mafrur Shati, lecturer of physics, Square High School and College. Today I am going to give my lecture from chapter 6, that is the effect of heat on matter. Today's topics are thermal expansion of matter, linear expansion of solid. So at first, you have to know what is thermal expansion. Increase in size of any object like solid, liquid and gas on heating is called thermal expansion. In the figure, you can see the initial length is changed due to application of heat. So as a result, the volume can be changed. Look at the figure, at this figure, example of thermal expansions in liquid. So what is thermal expansion? Again, I want to make you clear. It is defined as a change in dimensions of a body accompanying a change in temperature. Thermal expansions are of three types: linear expansion, area expansion, and volume expansion. But we can see in case of solid, there are three types of expansion: linear, area, and volume. But in case of liquid and gas, only volumetric expansion is seen. At the same temperature, the gas expands greater than liquid and solid, that you can see in the figure. Now I will give you some examples of thermal expansion in our daily life. Look, jar lids and power lines. It is an everyday experience that tight metal lids are easy to remove after passage of hot water over them. Sometimes it happens when you are trying to open the lid but you can't because uh, the lid is tightly fitted on the jar. So in that case, you will pour some hot water over the lid and it will be very easy to open the lid. Sagging of electrical power lines is another example of thermal expansion. Here sagging in Bengali it means ঝুলে পড়া. কি হয় যে thermal expansion that means for the heat of sunshine তারগুলো কি হয় যে কারেন্টের যে লাইনগুলো সেগুলো কি হয় ঝুলে পড়ে due to thermal expansion in the summer season. Look, in this figure you can see the if you pour hot water in the cup may be cracked. Here in this figure you can see when gas particles get hot, they take up more spaces and they expand. Thermal expansion of solid. Now I will explain it. Almost all the substances expand due to application of heat and contract for the extraction of heat. When a body is heated, the heat energy and as such the kinetic energy of each molecule of the body increases. In solids, the molecules vibrate with enhanced energy against the intermolecular force, and as a result the displacement of the molecules from their equilibrium position increases. Here you can see the molecules are vibrating due to the application of heat and they are vibrating in their respective equilibrium position. But if you apply more heat, then the molecules will be free from their intermolecular force and they will be displaced from their equilibrium position. So we can imagine a solid as a collection of many molecules. We can compare the molecular forces among them with a spring. We have imagined a spring among molecules to show how molecules are arranged. When the solid is heated, its molecules will vibrate. The higher the temperature, the more the molecules will vibrate. We have to improve this spring model to some extent to explain the real nature of solid in the next slide. Look, here these are the molecules, and here between the molecules I have shown you some spring. Here this is an imaginary spring, not real spring. Okay, the molecules are connected with each other by an imaginary spring. You know, from the elasticity, when I have discussed elasticity at that time, you know, in case of a spring, the force by which it is pulled when it is expanded to a certain distance, and it pushes by the same force when it is compressed by the same amount. This is not true completely for the molecules of a solid. Here we have used a model, spring model. For that case, the nature of the real spring is not completely true. The amount of force by which molecules pull each other when they are moved away to a certain distance, they push themselves by much more force when they are brought close to each other by the same distance. Look, here in the figure, the molecules are moved away from each other far distance, but when here less force is applied to move them far distance, but more force will be required to take them closer. Now imagine that the molecules are vibrating due to a certain temperature. For being a special type of spring, during vibration, molecules do not come very near but can move further away. Now, if the solid is heated more, the molecule will vibrate much more. Look here in the figure, the molecules are vibrating due to the application of heat, and for when the molecule, due to the application of heat, they vibrate and they expanded outwardly rather than the inward direction. When all molecules will move away from one another, the whole solid seems to be expanded slightly. Length, breadth, and height of a solid are expanded equally in three directions by the application of heat. To analyze this expansion, three quantities named coefficient of linear expansion, coefficient of area expansion, and coefficient of volume expansion been introduced. Linear expansion of solid and coefficient of linear expansion. At first, I want to give you the definition of linear expansion of solid. When heat is applied to a solid substance, elongation of its length occurs towards a definite direction, and the expansion along its length is called linear expansion. Look here, I have underlined this linear expansion because you have to memorize this definition. It may come as your knowledge-based question. Look in the figure, at theta 1 degree temperature, the initial length of the solid rod or solid bar is L1. As temperature increases to theta 2, then the length becomes L2. Now I will calculate the coefficient of linear expansion. So let the length of the bar at temperature theta 1 be L1 and at temperature theta 2 be L2. So increase in length is what? L2 minus L1. Look in the figure. And increase in temperature is theta 2 minus theta 1. The coefficient of linear expansion is denoted by alpha and can be expressed as this equation, alpha equal to L2 minus L1 by L1 into theta 2 minus theta 1. It means increase in length divided by initial length into increase in temperature. So what should be the unit of coefficient of linear expansion? I think you can calculate it. Its unit will be per Kelvin. Here in the figure, you can see the length of the solid bar is increasing due to the application of heat. Now, I want to give the definition of coefficient of linear expansion. The increase in length of a solid of rod of 1 meter for a rise of temperature of 1 Kelvin is defined as the coefficient of linear expansion of the material of the solid, and its unit is per Kelvin or K inverse 1. Dear student, I always tell you one thing, that no need to memorize any definition. You just feel it. You just understand it. You just try to understand it. Look, coefficient of linear expansion means what? If the length of the rod is 1 meter and increasing temperature is 1 Kelvin. That means theta 2 minus theta 1 equal to 1 Kelvin. Then alpha equal to L2 minus L1. From here, from these equation, you can give the definition of alpha, that is coefficient of linear expansion of solid. Here L2 minus L1 means what? Increase in length. Increase in length, in which case? When the length of the initial length of the rod is 1 meter and for the raise of 1 Kelvin temperature. Okay. Sorry. So the increase in length of a solid rod of 1 meter for a rise of temperature of 1 Kelvin is defined as the coefficient of linear expansion of the material of the solid. The coefficient of linear expansion of copper is 16.7 into 10 to the power minus 6 per Kelvin. What does it mean? It means if the temperature of the copper rod is raised through 1 Kelvin, then its length increases by 16.7 into 10 to the minus 6 meter, where the original length of the copper rod was 1 meter. Dear student, sometimes this type of question can come in your realization based question which carries 2 marks. Why a gap is kept at the joining point of 2 rails of a rail line. I think all of you have experience to go to the railway station, and if you would look very carefully, then you can see there is gap between 2 rails. Okay, that is not a single rail line. There is a gap between 2 rails. So why this gap is kept? The rails expand due to heat of the sun or due to the heat produced by the friction between the wheels and rails while the train runs. For this expansion, sufficient space is kept between the 2 rails. If gaps between the rails are not kept, the rail line will bend due to its expansion. Look at this figure. Look, here the rail line is bent because there was no gap kept between the rail tracks or rails, between the 2 rails. Now, I will show you a mathematical problem. The length of a steel rod is 100 meter at 20 degrees Celsius. If its length becomes 100.033 meter at 50 degrees Celsius, then determine the coefficient of linear expansion of steel. So, coefficient of linear expansion of steel. For finding these things are given in the question. Initial length L1 is 100 meter. Final length L2 equal to 100.033 meter. Initial temperature theta 1 equal to 20 degrees Celsius. Final temperature 50 degrees Celsius. Increase in temperature theta 2 minus theta 1 equal to 30 degrees Celsius. But you have to remember one thing. Increase in temperature for 1 degree Celsius equal to 1 Kelvin. That means 30 degrees Celsius can be written as 30 Kelvin. Increase in length L2 minus L1 equal to 0.033 meter. And you have to find out coefficient of linear expansion. Alpha equal to what? So for finding alpha, the formula should be alpha equal to L2 minus L1 by L1 into theta 2 minus theta 1. Now put down the value in the formula. Then it becomes 11 into 10 to the power minus 6 per Kelvin. Okay. This type of math you have to practice, because the more you practice, the more you will learn. Dear students, now I will show you an interesting and intriguing experiment which proves the thermal expansion of solid. So let's enjoy the video. Thermal expansion. Thermal expansion. Most substances expand on heating and contract on cooling. The expansion of a substance on heating is called thermal expansion of the substance. Gravesand's ball and ring experiment. Gravesand's ball and ring experiment can demonstrate that solids generally expand on heating and contract on cooling. A metallic ball just able to slip through a ring at room temperature is taken. Ball is heated for some time. An attempt is made to pass the heated ball through the ring. The ball does not pass through the ring. If the ball is cooled in room temperature, it is found to pass through the ring. Now, thermal expansion in terms of kinetic energy. According to kinetic theory of matter, average kinetic energy of molecules of substance increases with increase in temperature. Molecules therefore move more vigorously and the mean distance between the molecules increases. That results in an increase in length, area and volume of the substance. On cooling the substance, the kinetic energy of the molecules decreases, which results in contraction in length, area and volume of the substance. Dear students, from the above explanation, I think you can understand my class. If there is any problem, you can message to me. There is a nice moral for you. You cannot change your future, but you can change your habits. And surely your habits will change your future. Dear students, this is my last class before the Eid vacation. So till then, stay safe and strong. Eid Mubarak to all.